Hello again, we're back. This is Mr. V. Hill. Today we're going to be talking about inverse variation. And so an inverse variation, we've got the definition up here. It's just a function of the form y is equal to some number k, this time divided by x. Okay. And what we say here is that y varies inversely with x. We could, of course, rewrite this as y is equal to k times 1 over x. So what we see here is that y is now varying directly with the multiplicative inverse of x, or the reciprocal. And that's why we call it y varying inversely with x, or an inverse variation. One example we might look at here is y is equal to 12 divided by x, where this value k is just 12. And we could make a little table just to get a feel for this thing. And just like before, we'll look at -3, -2, -1, 0, 1, 2, and 3, just for simplicity's sake. And so we plug in these x values. 12 divided by -3 is going to give us a -4. 12 divided by -2 would be -6. 12 divided by -1 is going to be -12. Try to plug in 0 though here. 12 divided by 0, well, we can't do that. There's going to be an error here if we plug that into our calculator. Just you can't divide by 0 in the real numbers. But then 12 divided by 1, there we go, that's going to be as 12. 12 divided by 2 is 6. 12 divided by 3 would be 4. And so we might notice here that as our x's are going up by 1 each time, well, here y is going up, or excuse me, going down by 2, and then down by 6. Oops, so this thing is most definitely not linear. And we notice here also with this point, well, it's not even a point really, is that x can't be 0. So this is definitely a little bit different from what we've looked at before. If we were to graph this thing, I've already got it typed in here, y is equal to 12 divided by x. Let's graph it. Whoa, okay. That's definitely different. We have not seen something like this yet. Most definitely not linear. And we have two different pieces to the graph as well. And of course here on this y-axis where the x is 0, well, there's not going to be a point there. This has no y-intercept, because we can't plug in 0 here for x. And so if we think about this, as the x's keep getting smaller and smaller and smaller but staying positive, 12 divided by a really small number, well, that's going to be a really big number. So that's why this part of the graph is climbing really steeply. And it's going to keep getting steeper and steeper and steeper, but it won't ever actually touch the y-axis. On the other side here, as the x's get closer and closer to 0 but negative, then we have 12 divided by a really small negative number. Small in absolute value, I mean. So that's going to be a very big number, but it's going to be negative. So that's where this part of the graph is shooting off down like this. And again, it won't ever touch the y-axis. Now also, as the x's get really big in the positive direction, 12 divided by a very large number is going to be very small, but it'll always stay positive. So on this side, the y's are going to get smaller and smaller and smaller, so this part of the graph is going to shoot off this way, but it's never going to touch this x-axis. As we get huge and negative going this direction, again, 12 divided by a huge number is going to be small, but we're divided by a negative number, so it's going to be a negative number that's very small. And of course, 12 divided by a negative is going to be a negative, so it's never going to touch this x-axis either. So here, the axes, excuse me, are called asymptotes. And you may have heard that before, I hope. The asymptotes being lines that the graph will get closer and closer and closer to, but won't actually touch. So just to give a little sketch here so we can talk about it. The graph is going to look a little something like this, where we have this part of the graph over here, and this part of the graph over here. And this shape actually has a name. It's called a hyperbola. I think I mentioned this a little bit in class as opposed to a parabola, but this is another one of our conic sections. And we'll talk about that a little bit more just to review that. Now, how we might identify that something is an inverse variation, not just by the shape of the graph, but even if we just have a table, what we might notice is if we take this equation, y is equal to 12 divided by x, and we multiply both sides by x, well, these x's over here are going to cancel out, and we have x times y is going to be always equal to 12. So now, instead of the ratio of y to x equaling some constant value, now we have the product equaling the constant value. So the product of x and y is always the same. And it's always going to be this number k. And again, we call that the constant of variation. Just like with direct variations. And again, so if we look at this table, negative 3 times negative 4, that's positive 12. That number right there. Negative 2 times negative 6, 12. Negative 1 times negative 12, 12. We have a problem with this point, of course, because x can't be 0. But down here, 1 times 12 is 12, 2 times 6, 12, 3 times 4, 12, and we see that always with inverse variations. Okay, we'll play around with these some more in class. See you then.